Hello everyone, welcome back to your own mathematics channel asm.geniusjunction. I am Abhishek sir, your mathematics mentor. In today's video, we are going to cover paper 6 of 9709, unit 2, Poisson distribution. This is your video number 3 and this video is in continuation with video number 1 and video number 2. So I suggest to please go through with video number 1 and video number 2 so that you can effectively understand what we have covered in video number 3. The topics which we are going to cover in this particular video are the Poisson distribution as an approximation to binomial distribution, the normal distribution as an approximation to the Poisson distribution, and the last topic is hypothesis testing with the Poisson distribution. All these three topics are very important from examination point of view, as there will be approximately 8 to 10 marks questions which can come up from this particular topic. So be focused and let's move on without wasting time. For binomial distribution, when the value of n becomes very large and the value of p is small such that the value of np is moderate, that is, the value of n becomes large means more than 50 and the value of np is small, that is, product of n times p is less than 5. In this case, the Poisson distribution with mean is equals to np can be used as an approximation for the binomial distribution. To understand what we mean by above definition, let's go through with this particular question. Question says that a company produces electrical components. Past record shows that the proportion of faulty components is 0.4%. This is your P, and you can see that the value of P is going to be very small. When I will convert it to decimals, Harry buys a box of 1000 electrical components. Using the suitable approximation, work out the probability that more than 5 components are faulty. In these types of questions, understand that we need to use an approximation distribution. So first of all, let's start with the solution of this question. So the given conditions are number of components taken as 1000, the value of success is given as 0.4 and it is given in percent. So first of all, I will write this percentage into decimals. It becomes equals to 0.004, right? So here we can see that the value of n is large. And when I say value of n is large, I actually mean that n is greater than 50. Okay. Also, the product n times p is equals to 1000 times 0.004, that is actually equals to 4. Okay, which is less than 5, that is n times p is less than 5. Okay, so the two conditions are exactly met out. So I will write, therefore the Poisson distribution x follows binomial distribution first of all with 1000 components and success rate is 0.004, and we can approximate, it can be approximated by Poisson distribution with mean going to be 4. Now if we read the question very carefully, we can see that he wants you to work out the probability that more than 5 components are faulty. Okay, so more than 5 components are faulty means that according to question, we need to find the probability of x greater than 5. And for this, I will calculate 1 minus probability of x is equals to 0, 1, 2, 3, 4, and 5. So let's calculate this. 1 minus e raised to the power minus 4 is going to be common. Then for 0 it is 1, and for 1 it is 4 itself. Then I will write 4 square over 2 factorial then 4 raised to the power 3 over 3 factorial, then 4 raised to the power 4 over 4 factorial, and 4 raised to the power 5 over 5 factorial. So let's finally calculate the given expression, and when we solve we get 0.21050. So we will write, therefore probability of x greater than 5 for the given question is 0.2150. So this is the solution for the given question. Please note down the solution so that we can proceed further for the next question. Now we have reached on next question of this video, where we are given a random variable x, where x follows a binomial distribution. Here we can see that x follows binomial with number of trials as 120, and you can see that the value of p is very small. We will use a suitable approximation to find the probability of x less than or equals to 5, and we need to calculate the probability of x greater than 2. So let's start with this. First of all, we will calculate the probability of x less than or equals to 5 for part A. So this is your x less than or equals to 5. It is to be calculated, and we are given x which follows a binomial distribution with the number of trials 120 and success as 0.02. I will write two things. First, n times p is 120 times 0.02. This is going to give you 2.4, which is less than 5, and the value of n is 120, which is greater than 50. So two conditions are met out. So I will write, therefore given binomial distribution can be approximated by Poisson distribution, and the mean for the Poisson distribution is going to be 2.4. Now we are going to calculate probability of x less than or equals to 5, and this is going to equals to e raised to the power minus 2.4 times probability of x is equals to 0, 1, 2, 3, 4 and 5. So I will write it right over here only. This is right, e raised to the power minus 2.4 bracket 1 plus 2.4 plus 2.4 square over 2 factorial, 2.4 raised to the power 3 over 3 factorial, 2.4 raised to the power 4 over 4 factorial, and the last one as 2.4 raised to the power 5 over 5 factorial. When we will solve the complete expression by using calculator, we are going to get the final answer as 0.964. So we will say that this is the answer for the first part of the question. Okay, so now let's move back to the question, and in the P part, question is asking us to calculate the probability of x greater than 2. So let's keep on moving to the next part. This is your part B, where question is saying find the probability of x greater than 2. Here again we know that it is x is following a Poisson distribution and mean is 2.4. So greater than 2 will be calculated as 1 minus probability of x is equals to 0, 1, 2. So we need to calculate these probabilities and then we will subtract it from 1. I will write it as 1 minus e raised to the power minus 2.4 bracket 1 plus 2.4 plus 2.4 square over 2 factorial. Yes, so we are going to use the calculator to find out the value of this expression. So let's quickly use calculator to find out the value of this expression. This is 1 minus e raised to the power minus 2.4. Then we will open up the bracket. In the bracket we are having 1 plus 2.4 plus 2.4 square and divided by 2. Okay, so keep the bracket closed and we are getting the final answer as 0.430. So we will write that this is the final answer for the given question, part B. Please note down the solutions quickly so that we can move on to next question of this video. Yes, so maintaining the pace, we have reached on next question in this video, where the question says that past records show that the proportion of the faulty registers manufactured by the company is 0.2%. Robert buys a box of 450 registers. Using the approximate distribution, work out the probability that fewer than 3 registers are faulty. So let's quickly use Poisson distribution to solve this question. Yes, so let's start with the solution of the given question and let's see how to solve it. Okay, so in this question we are given that the value of n is 450 and the value of p is 0.2%, which we convert to decimal, we get 0.002, right? Furthermore, if I calculate n times p, we will be having 450 times 0.002, 450 times 0.002, so we are getting 0.9, which is again a very small value, which is going to be less than 5, and the value of n is 450, which is again greater than 5. So by looking at the scenarios, both the condition 1 and condition 2 is satisfied for the given binomial distribution question to be approximated by Poisson distribution, and mean is going to remain 0.9 for that. Okay, so now if we read the question again, question is saying that using the approximation, work out the probability that fewer than 3 registers are faulty. So according to question, probability to be found is for fewer than 3 registers are faulty. So fewer than 3 actually means e raised to power minus 0.9 times 1 plus 0.9 plus 0.9 square over 2 factorial, which is 2 only. Okay, so let's quickly use the values of this particular expression by using calculator. We will write e raised to power minus 0.9 bracket 1 plus 0.9 plus 0.9 square over 2. So we are getting the final answer as 0.937. So this is the answer for the given question. Okay, so let's keep on moving to the next questions of this video to increase our understanding. Yeah, so now we have reached on the next question of Poisson distribution, and this question states that there is a machine which is known to produce defective components. Two keywords which are given as at random and independently of each other on an average of 0.24% of the time. If I will convert this 0.24% in decimals, it will be a very small value. In the production of 500 components, state a suitable approximating distribution and calculate the probability that at most 3 components will be defective. So let's start with the solution of this question. First of all, we will write down the things which are already given to us, and then we will start with the solution of that. Yes, so in this question we are given number of items as 500, and we are given that the value of P, that is producing an defective component, is 0.24%, which is when converted into decimal gives you the value as 0.0024. Okay, so we will calculate we will calculate n times p, 500 times 0.0024. This gives us the value as 1.2. Now we will write down the two important conditions. Condition number 1, that the value of n is 500, which is greater than 50, right? And then condition number 2, which says that the value of np is 1.2, which is less than 5. So these two conditions are met out, so we can say therefore x, which follows binomial distribution with number of trials as 500 and success rate as 0.0024, can be approximated by Poisson distribution with mean as 1.2. So till now we have understood that the given expression of binomial distribution will be approximated by using Poisson distribution. So now according to question, if we read that very carefully, we can see that they want us to find out the probability that at most 3 components will be defective. So we need to calculate the probability of p of x to be less than or equals to 3. For this, we will calculate probability of x is equals to 0, 1, 2, and 3. How we calculate this? We will write down e raised to power minus 1.2, and then for 0 it is going to be 1, for 1 it is 1.2 itself. Then I will write 1.2 square over 2 factorial. Then I will write 1.2 raised to power 3 over 3 factorial. Let's close the brackets. Using calculator to get the final answer as 0.966. So this is our given answer for the given question. Please pause the video and note down the solution for this question. Okay, so now this is the time to move on to next important question of this particular topic. Yes, so now we have reached on next question of the same topic, and in this question we are given that for a certain flower a seed mutation occurs at random with the probability of 0.0004. Again you can see that the value of p is given as very small. A total of 12,000 seeds germinate. Let x be the number of seeds that germinate and carry mutation. Now question number 1 of it says justify using the Poisson distribution. So they already stated that the given question is need to be done with the Poisson distribution as an approximating distribution for x. In part B, they want you to use your approximating distribution to find probability of x less than equals to 3. And in C part is very important, because in C part they want you to calculate the probability of x less than equals to 3 given that x is greater than 1. This is actually a question which is based on conditional probability. So this is the very good level question. Let's start with the solution of it. Let's see how we need to solve these types of questions when comes in examination. So this is your solution. First of all, I will write down all the important things which are given in this question. Yes, so first of all, let's quickly write down the given things which are already stated in the question. So n is given to us as 12,000. We know that it is given greater than 50. So our condition number 1 is already met, that the value of n should be greater than 50. Then moving further, we noticed that value of p is given as 0.0004, and since it is very small, so if I will calculate n times p, that is 12,000 times 0.0004, we are getting 4.8, and again this is less than 5. So we can see that two conditions are met out, right? So when these two conditions are met out, we will write that since number 1 n is greater than 50 and number 2 np is less than 5, so therefore the given distribution can be approximated by using Poisson distribution. Okay, so let's write down the expression for binomial distribution. So x is following binomial distribution with number of trials as 12,000, success as 0.0004, and now we need to convert this expression to Poisson distribution. So we are writing that can be approximated by, and now we are approximating the given distribution x with Poisson distribution with mean as 4.8. Now, according to question in part 1, they want you to justify the use of Poisson distribution as an approximating distribution for x. So I will write the answer as, in part A, I will write that since n is greater than 50 and np is less than 5, therefore binomial distribution can be approximated by Poisson distribution. A few of the times a student asked me that whether we need to apply the continuity correction or not. So I'm just making a box over here and I'm writing it in bold that no continuity correction is applied when binomial distribution is approximated by Poisson distribution. You need to understand that both the distributions are random discrete variable distributions, and when both of them are of the same category, we do not apply continuity correction. Okay, so moving further, let's move on to B part of the question. In B part, they want you to use your approximating distribution to find probability of x less than equals to 3. So in part B, we need to find probability of x less than equals to 3, where x is following Poisson distribution with mean as 4.8. Okay, so for this we need to calculate probability of x is equals to 0, 1, 2, 3. Right, so we will write down e raised to the power minus 4.2 bracket open. For 0 it is going to be 1, for 1 it is 4.8, and for the other values I will write 4.8 raised to the power 2 over 2 factorial. Then I will write down 4.8 with raised to the power of 3 over 3 factorial, close the brackets. Now we will use our calculators to find out the answer as 0.294. So this is the final answer after calculating the things by using calculator. Yes, so now we are moving on to the third part, which is a very important one because it is following conditional probability concept. Yes, so in the C part, they want you to calculate the probability of x less than equals to 3 given that x is greater than 1. So this question is based on the concept of conditional probability. So let's start with the solution of it. In part C, we are given that we need to find probability of x less than equals to 3 given x is greater than 1. For this, we need to write down the formula first. So I will write that probability of x less than equals to 3 and greater than 1 will be there in the numerator, and probability of x greater than 1 will be your denominator. So solving this thing, we will write probability of x is equals to 2 comma 3, and in the denominator I will write probability of x greater than 1 is 1 minus probability of x is equals to 0, 1. That's it. So I will subtract the probability of 0 and 1 out of 1 so that we can get the probability of x greater than 1. Okay, so let's solve this by writing an expression for it. So I will write down e raised to the power minus 4.8 as common. For x is equals to 2, it is going to be 4.8 with exponent as 2 over 2 factorial, plus for 3 it is going to be 4.8 raised to the power 3 over 3 factorial, close the brackets. Then we are having 1 minus e raised to the power minus 4.8, open the brackets, it is 1 plus 4.8, close the brackets, And now when we will write down the final answer, it is going to be 0.259. So this is the solution for the given question. Please pause the video, note down the solution, understand the concept of conditional probability, do it and practice this again and again. These types of questions comes in examination. You need to practice these questions effectively to score good. Let's move on to next topic of this particular chapter. Yeah, so now we have reached on next topic of this particular chapter, that is Poisson distribution, the normal distribution as an approximation to Poisson distribution. Yes, you can see it right. Now we are going to approximate a Poisson distribution by using normal distribution. And for the lambda, which is going to be greater than 15, the Poisson distribution with mean as lambda can be reasonably approximated by the normal distribution, and for that mean is going to be lambda and variance is again going to be lambda. Important part is we will not forget to apply the continuity correction. Why we said that? Because normal distribution is a random continuous variable representation, whereas Poisson distribution is random discrete variable representation. The accuracy of this approximation improves as the value of lambda increases. Remember this thing because these are 1 markers which will be asked in the examination. Yes, so by using this table, we will understand how to approximate a question which is based on Poisson distribution by normal distribution. So first of all, I will write down that this is your heading for Poisson's distribution. This is your column for Poisson distribution, complete column. And the second column is for representing normal distribution. Okay. So now here it is. Let's have a quick look how we need to do a question. So in Poisson distribution, let's say that we are having an expression x which follows Poisson, and take an example of mean being equals to 24. And in case of Poisson to normal, we will write that y follows normal distribution with mean as 24 and variance as 24, because in Poisson distribution mean and variance both are equal. Now condition number 1, where we need to find probability of x is equals to, so when it is a question of Poisson distribution, this is very simple. I will write down e raised to the power minus 24 times 24 raised to the power 3 and then complete expression divided by 30 factorial. When you will solve this by using calculator, you will get 0.0363 as the solution for it. Now suppose if you are approximating the same question with normal distribution, then I will write it like probability of, I will write it as probability of y less than equals to 30.5 and greater than equals to 29.5, and to calculate this we need the z values. So we will write probability, that is 30.5 minus 24 complete expression over root 24 less than equals to z less than equals to, then I will write down 29.5 minus 24 divided by root 24, that is standard deviation. Okay, so when we will solve the question, we will get the final answer as area relevant to 1.327 minus area which is relevant to 1.123. Yes, so we will calculate the final answers for this. Yes, so when we will calculate these values, we will get 0.9077 minus 0.86792, and when solved by using calci, we get the final answer as 0.0385. Let's move on to understand some other examples of the same type. So in case of Poisson, your second question can come up where you need to calculate probability of x greater than 29 and less than 31. You can see in this question that x is greater than 29 and less than 31. Okay, so we will calculate it as e raised to the power minus 24 times 24 raised to the power 30, because it is only 30 which is left according to the question stated above conditions. This is 30 factorial, and again I'm going to get the same answer as 0.0363. Now, when we will approximate the same second question of Poisson distribution by normal distribution, I will write it as probability of y greater than equals to 29.5 and less than equals to 30.5. Now I will calculate the z values for this. So I will write it as probability. Then I will write 30.5 minus 24 divided by standard deviation, that is root 24, less than equals to z value, then less than equals to, and then z value for 29.5. This is 29.5 minus 24 divided by root 24. Close the brackets. When we will solve this further, we will get phi of 1.327 minus phi of 1.123. By using calculator, we can get the value as 0.0385. Now this is the second type of question in which there was only less than conditions involved, and we can see that we applied a continuity correction to solve the same question. Now let's move on to next type. Yes, so now in type 3 we are having a question based on Poisson distribution where we need to find the probability of x less than equals to 26, greater than equals to 24. So here we can see that the value of x is lying between 24 and 26. So I will write down probability of x equals 24, 25 and 26 and 26. For this we will write down e raised to the power minus 24 as common, and then I will write down 24 raised to the power 24 over 24 factorial plus 24 raised to the power 25 over 25 factorial plus 24 raised to the power 26 over 26 factorial. Close the brackets. By using calculator, we can get the final answer for the given question as 0.231. Now we are going to use normal distribution as an approximation to Poisson distribution. So we will write it as probability of y less than equals to 26.5. After applying continuity correction, it will become 26.5, and greater than equals to 23.5. This will be calculated as probability of z greater than 26.5 minus 24 complete expression divided by root 24, that is your standard deviation, less than equals to z value less than equals to, then we will put 23.5 minus 24 divided by root 24, right? When we will calculate the area functions for the given top values, we will get 0.510 minus area function relevant to minus 0.102. So we will write the answer as 0.6950 minus 1 minus 0.5406. Finally, you are getting the answer as 0.236. So here we can see that we have approximated a given Poisson distribution question by normal distribution. Do not forget to apply the continuity corrections whenever we are approximating a Poisson distribution question by normal distribution. So till now we have done 3 cases, and now we are moving on to a next very important case in which on the one side there is a inequality involved. This is your case number 4, in which we need to find the probability of x which is having the value less than equals to 21 and greater than from 19. So here you can see that x cannot be equal to 19, but it can be equal to 20 and 21. So we will calculate it as x is equals to 20 and 21. For this, I will write down e raised to the power minus 24. Open up the brackets. You will write down 24 raised to the power 20 over 20 factorial plus 24 raised to the power 21 over 21 factorial. Close the brackets. We will use calculator to find the answer as 0.134. Now suppose if the same question is to be approximated by using Poisson distribution to normal distribution. Now suppose if the same question is to be approximated by normal distribution, then this fourth case will be solved as probability of y greater than equals to 19.5 and less than equals to 21.5. Now we will calculate the z values. So we will write probability of having y between these two values. I will write down 21.5 minus 24 divided by root 24 standard deviation. Z values, then I will write down 19.5 minus 24 divided by root 24. Let's close the brackets. So we are having phi of minus 0.510 minus phi of minus 0.919. On solving this by using calculator, the final answer is 0.126. So again, you can see that now we have approximated a Poisson distribution by normal distribution in the fourth case also. So this is the way we need to do the questions. Please pause the video, note down the complete table, because this table is going to be very important when we will solve the question of Poisson distribution by normal distribution. Okay, so now we have read on a question part to understand how to approximate a Poisson distribution by using normal distribution. So in this question, we can see that over the years, a biologist notes that species of the turtle lays eggs on an average of 60 eggs in each nest. The number of eggs laid in each nest follows a Poisson distribution and is independent of the number of eggs laid in other nest. Calculate the probability that in a randomly chosen nest there are exactly 50 eggs, over 74 eggs, C part 40 eggs, or fewer than that. Okay, so now we need to solve this question. So let's start with the solution part. First of all, we will define x. So we will say that let x be the random variable. Let x be the random variable which represents number of eggs in a nest. Okay, so x is representing number of eggs laid by the turtle in the nest. Okay, so we will say then x is actually following Poisson distribution with mean as 60. Okay, so we can see that now it is Poisson distribution with mean as 60 because question was already saying that it is following Poisson distribution. You can see it right over here that since mean lambda is 60, which is actually greater than 15, so I will say therefore the given Poisson distribution can be approximated by normal distribution. So when I will solve a given question by normal distribution, we will write x, which is following Poisson distribution with mean as 60. Now it is following normal distribution, so we will write that x follows normal distribution with mean as 60 and variance as 60. Now let's go to the question part. What question is conveying to us? In part A, they want you to find the probability of x exactly equals to 50. So first of all, we will apply the continuity correction. So we will write down probability of z less than equals to and greater than equals to, and then for 50 we will write 49.5 minus 60 over root 60, and z is greater than equals to 50.5 minus 60 over root 60. So these are the possible areas of Z. Okay, so let's quickly find out the values. So we will write that phi of minus 1.226 minus phi of negative 1.356. When we will use the table of normal distribution, we can easily figure out that it is going to be 1 minus 0.8899. When you use table for this as well, it is again 1 minus 0.9125. And when finally solved by using calculator, we get the final answer as 0.0226. So this is the final answer for the given question. So this is the part A. Now let's move on to part B, where he's asking you to find the probability that x is greater than 74. Okay, so let's see how we need to approach B part of it. We need to find out probability of x greater than 74. When we need to find probability of x greater than 74, we will actually do it like 1 minus probability of x less than 75. Okay, so this is 1 minus, now this is less than 75, so we will apply continuity correction, and this becomes z less than equals to 74.5 minus 60 over root 60. Let's solve this further. So we will get 1 minus phi of 1.872. This is the calculated value. So for this, we will use normal distribution table. And when we use that table, we get the final answer as 1 minus 0.9693, which gives us the final answer as 0.0307. So this is the final answer for part B. Okay, so now let's move on to C part, where we need to find probability of x less than equals to 40. And in C part, again, we are going to apply the continuity correction. So we will write it as probability of z less than equals to 40.5 minus 60 over root 60. Let's close the brackets and figure out the value for this. So this is phi of minus 2.517. This gives you the final answer as 1 minus 0.9941, and the final answer for the given question becomes 0.0059. So this becomes the final answer for the given question. Okay, so I suggest you all to pause the video, note down the solutions, understand the concept, and then we will proceed further for the next question. Yes, so now we have reached on one more important question of the same video, where x is following a Poisson distribution with mean as 50, and question itself is suggesting to use normal distribution to find A part value of x between 52 to 56, and in B part x is lying between 50 and 52. So let's start with the solution part of it. So question is saying this is your solution for this question. Let's see how we need to proceed. So first of all, x is actually following Poisson distribution with mean as 50. Okay, we will approximate this normal distribution by writing that can be approximated by using normal distribution, and I will write that x follows normal distribution with mean as 50 and variance as 50. Now we need to solve the question with the expression x following normal distribution with mean and 50, variance is 50. So part A, it is saying that probability of x lying between 52 and 56. So let's proceed further. We will find out the probability of z with continuity correction, and this becomes 55.5 minus 50, complete expression divided by root 50. minus probability of z being less than or equals to 52.5 minus 50 complete expression divided by root 50. Now when we will solve this particular expression, we are going to get phi of 0.778 minus phi of 0.354. Let's solve this and we get 0.144 as the final answer after confirming it from the table. Okay, so this is the way we need to solve a question which is asking the existence of x between 52 and 56. Okay, so now let's move on to B part of this question where x is less than equals to 52 and greater than equals to 50. So this is your part B where question is saying find the probability of x being greater than equals to 50 and less than equals to 52. Again, we will apply continuity corrections. So we will say that z is less than equals to 52.5 minus 50 over root 50 minus probability of z being less than 49.5 minus 50 and complete expression divided by root 50. When we will solve this, we are getting the final expression as phi of 0.354 minus, for the second part, since it is a negative expression, I will write it as 1 minus phi of 0.071, and let's close the bracket. When we will solve this expression, so we will get the final answer as 0.167. So this is the answer for the B part of the same question. Pause the video, note down the solution, understand the concept, and we will proceed further. Okay, so now moving on to next question of the same video. Yes, so now we have reached on the next question of the topic where we are approximating a Poisson distribution by using normal distribution. In this question, Fabio receives on average 48 emails at work each day. Emails are received at random and independently, and Fabio can answer at most 60 emails each day. This is important, the number of emails which he can answer a particular day. Find the probability that on a randomly chosen day, Fabio can answer all emails received. Again, it's a very good question. These questions always checks our conceptual abilities to solve it. The level at which you have understood the concept and you have comprehended the language. So once you are pro with the comprehension of the question's language, any type of question becomes a simple question. So in this particular question, x is again following Poisson distribution with mean as 48 as already given. So we will say that since mean is equals to variance is equals to lambda is 48, which is greater than 15, therefore we will approximate Poisson distribution by normal distribution, right? So we will write x, which is following Poisson distribution with mean as 40, with normal distribution, that x is following normal distribution with mean as 48 and variance as 48. And now we will go to the question part where question is saying that we need to find the probability of x less than equals to 60. So let's proceed further. We will write down probability of z less than equals to, because it is less than equals to 60, so it will become 60.5 after applying continuity correction. Never forget to apply continuity correction while solving these types of questions, because Poisson distribution, don't forget that Poisson distribution is a random discrete variable, whereas normal distribution is random continuous variable. So we need to make sure that we are applying, I'm writing it over here, never forget to applying continuity correction. If we forget to apply continuity correction, all the efforts goes in vain. There is no use of making all these efforts because final answer is going to be wrong for us. So this is root 48 in the denominator. We have closed the brackets. Finally, when we will solve it, we get answer as phi of 1.804. Now you can use normal distribution table which is available in MF19. So we are going to get the final answer as 0.964. So this is the answer for the given question. Pause the video and note down the solution, and then we will move on to next question. Yes, so now we have reached on next question, where question is saying that x is following Poisson distribution and x is greater than x. The probability of it is less than equals to 0.1. Find the minimum integer value of x. Why I have taken this type of question in this video, because such type of question had come up in October series question paper and maximum students were puzzled how to solve that particular question. So to make students understand how to solve these types of questions, we have taken this question in the video. So let's proceed further how to solve these types of tricky questions, and let's see what they have actually given us, what they want us to find out. So x is actually following Poisson distribution with mean as 42, and since it is having lambda equals to 42, which is again greater than 15, so therefore I will say Poisson distribution can be approximated by using normal distribution now. So this is x following Poisson distribution with mean as 40. We will apply continuity correction and I will write down can be approximated by normal distribution, where mean is going to be 42 and variance is going to be 42. Let's now go to the question part, where x is having the probability of being greater than x, less than equals to 0.1. So what they actually want us to understand, this is important. Yes, this is something which they have given to us, so let's write down given right in front of it so that we can understand. This is something which is given to us and we need to find the minimum integer value for that. So first of all, we will try to calculate the left hand side, that is probability of x greater than x. So suppose if we are solving for Poisson distribution to normal distribution, we will calculate the value of z with continuity correction applied, and since it is greater than sign, so 0.5 is going to be added in the value of x. So this becomes x plus 0.5 minus 42 and complete expression divided by standard deviation, that is root 42. Let's proceed further. Since it is 0.1, we can say that it is going to be the negative value, so we will solve it as 1 minus phi of x minus 41.5 complete expression divided by root 42, and we are given that it is less than 0.1. Okay, so when we solve it further, we write it as phi of x minus 41.5 complete expression divided by root 42 is going to be greater than or equals to 0.9, because one has moved on the other side. So when we solve this, phi will move on the other side, so it becomes phi inverse. So I'll write it like for x minus 41.5 over root 42 is greater than equals to phi inverse of 0.9, and this gives you the value as, let's write it over here. So we are getting x minus 41.5 over root 42 greater than equals to 1.282. This is the values which we have taken from the table. Let's proceed. So we will get the value of x as greater than or equals to 49.808. Yes, so for this particular value, we can easily say that the integral value just greater than this is going to be 50. So I will write that x is equals to 50 is the integral value for x. So this is the answer for the given question. Please pause the video and note down the solution. Yes, so we have reached on next question of this topic, where we are having a number of errors made by the customer when using the online banking transaction each week follows a Poisson distribution with mean as 42. So question has itself disclosed that the distribution is actually following Poisson with mean as for 25. Okay, find the probability that there are more than 32 customers errors in the randomly chosen week, and B part says that Katya calculates that it is almost certain that number of customers errors on the randomly chosen day is greater than 11 and less than 39. Use calculations to show how Katya arrived at her conclusion, so that we need to show how she actually reached to the conclusion of what she has said. Okay, so we need to solve this question. So let's start with the solution part of it. So according to question, x is actually following Poisson distribution and the mean of Poisson is given as 25. Now we will say that since lambda is equals to 25, which is greater than 15, therefore the Poisson distribution can be approximated by using normal distribution. So we will write it as x, which is following Poisson distribution with mean as 25, can be approximated with x following normal distribution with mean 25 and variance 25. Okay, so now in part A, we need to find probability of x greater than 32, and this can be calculated by using probability of z value greater than 32.5 minus 25 over root 25. Let's close the bracket and then now solve it further. So we will write 1 minus, this is 1.5 after we calculate the values. And now let's solve this by using table of normal distribution using MF19. We can easily solve it as 0.0668. Now we are moving on B part, where question is saying that Katya calculates that it is almost certain that the number of customers errors on the randomly chosen day is greater than 11 and less than 39. So question is saying that probability of x being less than 39 and greater than 11, how we are going to calculate this? So we will calculate the z values for the question first. So this becomes probability of z less than 38.5 minus 25 over root 25 minus probability of z less than equals to, we will apply continuity correction because we are using normal distribution and it is a continuous variable question, minus 25 over root 25. Okay, so when we will solve this, we will get 2 times phi of 2.700 minus 1, because both the values are going to give you the same answer. So this is giving us as 0.993. Okay, so why we have used this concept? Because the curves are going to be symmetrical, so that's the reason we are using this thing. Okay, so this is the final answer for the given question. Please pause the video and note down the way we have solved this question. Then we proceed on the next question of this video. Okay, so now we have reached on the next topic of this video, where we are going to use hypothesis testing with Poisson distribution. Okay, so this is again very important topic from a scoring point of view, because now we are going to have hypothesis testing concept also, which is going to be used while solving a question by Poisson distribution. Okay, so let's start with the question. This question says that record shows 1% of the population has a positive reaction to a test for a particular allergy. In a village, 120 people are tested and 4 people have a positive reaction. Test at 5% significance level if there is any evidence of an increase in the population with a positive reaction for this particular allergy. So let's start with the solution of this question. So according to this question, X is actually following binomial distribution with the number of people involved in the test is 120 and success rate is 0.01. Okay, so we can approximate this distribution can be approximated by X following Poisson distribution with mean as 120 times 0.01, that is 1.2. So here we are going to use Poisson distribution to approximate this binomial distribution expression. And why we are doing this and why we need to do this, because there are two conditions which are met over here. First of all, n is greater than 50, and second condition is n times p is less than 5. So when these two conditions are met, binomial distribution can be approximated by Poisson distribution. This is already covered in the previous videos. So let's continue with the approximation of given expression with Poisson distribution. Let's state the null hypothesis. It states that lambda for the given question is 1.2 and the H1, that is alternate hypothesis. Let's write that alternate hypothesis. This hypothesis states that the value of lambda is greater than 1.2. Okay, because question is saying that any evidence which shows that there is an increase in the population with the positive reaction. So that's why we have taken alternate hypothesis as lambda greater than 1.2. Also, the significance level which is given to us in the question is 5%, and we are going to perform one tail test since H1 claims that lambda is greater than 1.2. We need to understand that whenever H1 is having a claim of greater than or less than, we always use one tail test. So here we are going to use one tail test. Let's have a normal distribution curve now. Okay, so in this curve we are going to have one tail test. So one tail test will be taken from the right hand side with significance level as 5%. Right there on the screen I have mentioned that. Okay, so let's proceed further. So we need to calculate the probability of X to be greater than or equals to 4. We can calculate it as 1 minus probability of X less than equals to 3 now. This can be calculated by using Poisson distribution as 1 minus e raised to power minus 1.2 bracket 1 plus 1.2 plus 1.2 raised to power 2 over 2 factorial plus 1.2 raised to power 3 over 3 factorial. Close the brackets. Let's calculate the final value for the given expression, and this becomes as 1 minus 0.9662. On solving this, we get the final answer as 0.0338. When we convert this particular expression into the percentage criteria, we get the answer as 3.38%. So now on the curve, we can easily see that 3.38% is represented right over here. This is 3.38%. We have marked the area with the red color, which is represented by probability of X greater than equals to 4. And we can see that this particular area is in the rejection region. So we will conclude from the given expression that as 3.38% is less than 5%, Therefore, we will reject null hypothesis we will always write an expression which is going to support the answer which we are claiming in the last. So we will write that there is evidence at 5% level of significance to suggest that in this village there has been increase in the population who react positively to the test for this particular allergy. Okay, so now we are done with the solution part of this particular question. Please pause the video, note down the solution which is there on the screen, and then we move on to next topic of hypothesis testing in Poisson distribution. Yes, so now we have reached on next very important question of this video, where we are having a question which is saying that the number of calls to a consumer hotline can be modeled by a Poisson distribution with mean as 62 in every 5 minutes. Here they have already disclosed that the distribution followed is Poisson distribution with 62 calls in 5 minutes interval. Selina believes this average is too low and observes the number of calls recorded during the randomly chosen 5-minute interval to be 70. Stating the null and alternative hypothesis test Selina's belief at 10% significance level. Okay, so now after reading this question, let's move on to the solution part of it. Solution for the given question. So here we need to write that H naught, that is null hypothesis, what it suggests to us. So null hypothesis says that mean should be equals to 62, whereas alternative hypothesis suggests that mean should be greater than 62. Okay, so these are the two hypotheses. This is your alternative hypothesis, claimed hypothesis, which we need to test, and this is our null hypothesis or established one, or the established hypothesis. So let's proceed with the solution part of it. First of all, we will write down that X follows Poisson distribution as expressed in the question with mean as 62, and since lambda is equals to 62, which is greater than 15, so I will write therefore the given Poisson distribution can be approximated by normal distribution. Okay, so I will write that X, which follows Poisson distribution with mean 62, can be written as X following normal distribution with mean 62 and variance 62. Okay, so now let's start with the solution part of it. Okay, so question says that find the probability of X greater than equals to 70 for the given question. It is a one-tailed test from the right hand side. We need to mention that significance level for the given question is stated as 10%. Okay, so keeping all these things in the consideration, let's calculate probability of X greater than equals to 70. we are approximating from Poisson to normal distribution, so definitely continuity correction should be applied. So this is probability of z greater than equals to, I will write it as 69.5 minus 62 complete expression divided by root 62. Let's close the brackets. This gives us the final answer as 1 minus phi of 0.953, and hence when we will calculate we get the final answer as 0.1703. So here we can see that when we convert it to percentage, it is going to be 17.03%, and this percent is actually greater than 10%. So I will write, it implies H naught is accepted. Please do not forget to write down the supportive statements in the end. That is, therefore, there are sufficient evidences which supports H naught. Okay. So this is the way we have done this particular question. Please pause the video, note down the solutions, and then we will move on to next question of this video. Yeah, so now we have reached on next question of this video, where we are going to use hypothesis testing in Poisson distribution. So let's read this question, what is given to us. So in a question it is given that at a certain company, machine faults occur randomly and at a constant mean rate of 1.5 per week. This line is sufficient to make us understand that it follows Poisson distribution. Following an overhaul of the machines, the company boss wishes to determine if the mean rate of machines faults have fallen. So this is going to be your H1. The number of machine faults recorded over 26 weeks is 28. Use a suitable approximation and test at 5% significance level whether the mean rate has fallen or not. So let's start with the solution of this. Hypothesis testing is a very important tool which is used in case of Poisson distribution questions. So first of all, we know that we are talking about 26 weeks in the question. So for a 26 week duration, first of all, what you need to do is convert the average accordingly. We understood how we need to do all these things in our video number 1. So your average rate is given as 1.5 per week. Okay. And now since we are talking about 26 week duration, so your new lambda is going to be 26 times 1.5, that is 39. So now I will write that x follows Poisson with mean as 26 can be approximated by using x following normal distribution with mean 26 and variance 26. So we are going to use approximation. So it is can be approximated by normal distribution. Do not forget to apply continuity correction. Okay, it is very important. Here in this question we need to mention your H naught, that is null hypothesis. Let's see what null hypothesis says. So null hypothesis says that mean is actually 39. Then your alternative hypothesis says that lambda should be less than 39, and according to question we are going to calculate probability of x less than equals to 28. Please do not forget that your significance level shared in this question is 5%. Okay, so probability of x less than equals to 28. can be calculated by using continuity correction as z less than equals to 28.5 minus 39 complete expression divided by root 39. Let's close the brackets and solve the question further. This will give us 1 minus phi of 1.681. Let's use your calculators and normal distribution table. You can use calculators as well, or you can use normal distribution table, depends on you. After using that, you can easily find out that the given expression is going to give you the final answer as 0.0464. When we convert it to percentage, we get the answer as 4.64%. You can see that it is less than 5% significance level. So final conclusion is going to be that therefore H naught is rejected. And do not forget to mention the conclusion statements. So we will write that there is sufficient evidence which supports that mean rate has fallen. You know that this was the language of the question, so we have written the final statement in the same language. Yes, so now I believe that you all have understood how to solve a question which is based on Poisson distribution in paper number 6. Please pause the video. Please practice all the questions which are shared in all the videos for this particular chapter. All the best for your test. Yes, so with this question, we are done with the complete chapter of Poisson distribution. I suggest you all to watch all the videos effectively, note down the questions, do them, practice them, and then we will have one more video based on the same topic, and that will be having all the past year questions which have been asked by the Cambridge in the last few papers. So till then, you can practice and memorize the concepts which are very important to solve the question of Poisson distribution in examination. Please do not forget to like, share and subscribe the channel so that you can get timely updates whenever a video is rolled out. Thank you.